Our principal sir, Professor Devdatta Ghosh, my co-coordinator of AICTE HIT Idea Lab, Professor Dibyendu Chaudhary from ECE department, and Mohan Patro, who is also a member of this Idea Lab, and all my dear students. So I welcome you all to this 2 months long internship program conducted by AICTE HIT Idea Lab. So at the outset, I would like to request our principal, Dr. Subrata Mondal, to enlighten us with his speech.
Good afternoon. Happy New Year. Actually, after the end of this year, whether it is happy or not, then you will identify. But now I expected that year in total year will go for you very good. I think you will be serious in education. You will spend your time with good work. I think everything will be normal. Academic environment will be maintained. We can expect it. Then we can call it a happy new year. Okay. Today you have come here for attending the internship program, which is now mandatory for your course curriculum. Because new education, as per new education policy, this is a judicious mixture of theory and practical in your new education curriculum. So when you go for internship, then you will get some exposure on practical field. You will get that exposure. Actually, one thing you will believe, when you will hear anything, then you will forget. Okay, when you will see, you can remember, and when you will do, that is your expertise. That will be your expertise. So this is your chance as per academic curricula, as well as opportunity offered by your department, I mean mechanical engineering department. So you utilize it fully, because this is your benefits. When you will prove yourself, then nobody can stop you. So you have to prove yourself for our future establishment, future success, and we believe when you will get the success, our institute name will be more and more. Thank you all.
Thank you, sir, for your word of wisdom. Now I'd like to request Professor Devdatta Ghosh from AIE department, as well as he is the convener of IIPC cell, and he is my co-coordinator in this AICTE Idea Lab. So I'd like to request him to say a few words.
Good afternoon. Okay, so as Professor Subrata Mondal sir said, whether this year will be happy or unhappy, that would be decided at the end, right? But 2022 was quite good for our institute because we have added many facilities. AICTE Idea Lab is one of them. And we are very quickly establishing a incubation center, and if you are interested, you can also be the part of the incubation center just upstairs, first floor of Idea Lab. So after organizing many events like skilling program, faculty development program, awareness program for the schools, now finally we are coming into the curriculum. So today we will be starting internship program for 2 months, and you will be getting all necessary certificates on the paper which will suffice the purpose of the syllabus. And at the same time, during the internship, not only you will learn, you will do something, right? You will develop something, and we expect that you will come out with some effective prototype, right? By using the facilities in the Idea Laboratory. Though the internship is based on 3D printing, but we have decided that we will not keep yourself only in the boundary of 3D printing. We will expose you in other facilities as well, so that you can realize one effective mechatronics application. That's the purpose of this laboratory. And once you do that, in future you may have your own startup, because right at this moment we do not have any official startup. Many students are doing unofficially, privately, but they're not getting documented. But being one of the biggest institute in West Bengal, we should have our own startup. This is where we are lagging. Shortly, you will get the information about Institute Innovation Council. Since you are the first batch of internship, so you will be the de facto member of that council, right? Where many activities will be there, you try to sync with those activities, right? Because nowadays, through the activities, through the work, you have to learn. And once you learn, once you have the skill, nobody can stop you, right? Job is automatic. Even you can have your own job, right? So that is the objective. We'll talk about Idea Laboratories more rigorously afterwards. Today, from my side, it's best of luck. Let us spend these 2 months very effectively. Let us take something intangible, though, but it should help or nourish our future in the right direction. Thank you very much.
Thank you, sir, with your words of wisdom. Now, this internship program, as our eminent personalities have said, it is quite mandatory nowadays for all the engineering students, right? Those who are having the engineering qualification, whether it's an engineering or technology, okay, bachelor's of engineering or bachelor's of technology, all of you should be exposed to practical knowledge. And that is possible not only by the limitations of your laboratory, but also through internships as well as vocational training, summer training. Okay, so all these kind of avenues you have to venture out, because what companies are looking, ready-made products. Okay, so directly they will put you into job, because 6 months, 8 months of training in their organization is adding cost to the overhead of a company. So if you are capable enough, see what the computer science students are doing. Companies are recruiting, and while they are in the 7th semester or 6th semester onwards, they have been trained with the tune of the company. Okay, so that they will learn certain aspect in here in the institute. Directly when they will be passing 8th semester, they will be put on job. So this training period is getting reduced, or companies are reducing this training period, and they are trying to inculcate those training aspect in the education, in academics, such that when the students are passing out, they will be directly inducted in the job. Okay, so that's what we are trying to give you, because in core, still after getting recruited, you will be given the training program. But nowadays, slowly, that training duration is getting shortened. If you are well equipped with the knowledge of practical experience, probably you will have an edge in the company to work in a better position, because company will always prefer an experienced person rather than a novice. When you will be joining a company, if you are knowledgeable with respect to practical experience, you are at a higher position. Okay, that you can do by gaining experience in this training program, internship program, vocational training, summer trainings, all those. If you add those trainings into your CV, that will provide an impetus in getting a job. Okay, company wants how much practical knowledge you have, whether you are capable enough of doing things practically. So practical knowledge is the last word in industry. If you are knowledgeable in practical sense, sky is the limit. They will not go for what degrees you are having. You might be a topper in class, but that doesn't prove that you can perform well in an industry. Okay, so normally we haven't seen toppers are the leaders in industry. It's not like that. You can be a topper, you can be university, first class, first, doesn't guarantee that you will succeed in an industry. In an industry, it's a different ball game altogether. you have to do and give practical outputs. You have to deliver for the company. If you are having practical experience, practical knowledge, you have to improvise things. You have to take decisions. It's only decision making in industry. Okay, so how quickly you can make decisions? If 9 out of your 10 decisions are correct, you are hero. Okay, so it's only the decisions you have to take, right decision at the right time. So that only give you the impetus in growing in an industry. Otherwise, you can be very good in strength of materials. It doesn't matter if you don't know the application. Okay, if you are very good in, let's say, 3D printing, you know everything of 3D printing, but you don't know how to work in 3D printing, what is the practical aspect of 3D printing and how benefit the industry will be, you are of no use. Whatever knowledge you are having, for mechanical I am telling you, you have to give it a practical avenue for that. Then only the company will give you recognition. Otherwise, it's of no use. Okay, simply by learning, you are doing classes, fantastic. You are doing all the classes, all the labs. But what about the practical knowledge? Are you being able to run the equipment that are there in the lab on your own? Are you going to repair? Do you have the capability of repairing it? Do you have the capability of diagnosing it when it is not working? Or fault finding? That's what is required. That's what it is required. So in engineer, see, we take an engineer who can repair the bulb or fuse in his house. You can do that, you are taking the first step of an engineer. We do it from our home. If you can change the bulb, repair the fuse, okay, you are an engineer. Okay, or in the lab, what you are using your equipments and mechanisms. Have you ever studied how it works? If there is any fault in the machine, what are the faults? Can you detect the fault? Can you repair or avert any abnormality? Those things you have to venture out. That is the practical aspect of engineering. Otherwise, see, in Google, there are millions of lectures, millions of videos, every stuff is there in Google. Anybody who is willing to learn anything, Google is the way. But what about the practical aspect? Google won't give you a practical aspect of life. I can take n number of classes teaching you how to swim. All the mechanics of swimming, forces, dynamics of fluid flow, I can teach you everything. Then I tell you, well, I have taught you everything about swimming and put you in the pond. Can you swim? Why? Because I have told everything. How, at what angle, what thrust you have to give in the water, how will you paddle, what will be the fluid flow over your body, everything will be taught. But ultimately, you have to swim on your own in water. That is what industry is like. You have to learn how to swim. Then only you can develop yourself. Okay, so today we will be starting with the classes on this internship. It's of 2 months of internship. Mainly from Monday to Friday we will be taking the internship program in the second half because of your morning sessions engagement in theory and lab programs. So we have blended this program with theory as well as practical. Okay, so 1.5 hours of theory and then you'll go to the lab for getting the hands-on experience. And in the later half of this internship program, we will be giving you projects that you have to accomplish. We will be forming groups, okay, and each group will be given individual projects, and that working projects you have to deliver. Okay, that will be your assignment. In the meantime, there will be some examination for evaluation also, and finally you have to make a report and a working project in groups. That's how we have planned. Okay, so thank you one and all. So it will be a long journey starting today. Thank you very much. Thank you, sir. Okay, so it's a 3D object which can be created by layer deposition of materials. So you can think of a laminar deposition or a planar deposition in layers to get the 3D object. Okay. So this is a new concept which is being developed for making products or manufacturing products. So why we are saying the word additive manufacturing, we are adding materials, any materials like metal, ceramic, clay, polymer, functionally graded material. So various types of materials are now being explored to have 3D objects. So we are manufacturing the objects, right? Now in manufacturing, the process starts with development of the object in the design stage, right? Then validating the design, because in a design you will find various specifications, dimensions are required. Those who are having the third year classes are having design, right? Yes. So in a design you have a lot of calculations. In developing, let's say a tailstock you are designing. So all the design aspects of tailstock pertaining to the dimensions, pertaining to the tolerances have to be calculated. Then the strength part has to be calculated. Okay. Then the stress analysis has to be calculated. Then the temperature analysis has to be calculated. So a lot of calculations are there. Then when all those calculations validate the design, then you go for prototyping. Right. Now in prototyping also you do various kinds of tests like static tests and dynamic tests. Okay. Then you go for the failure analysis, and then you go for the actual validation prototype to the final product after the amendments or corrections are done in the prototype. So this takes a hell lot of time. Okay, so when you are trying to develop some new product, so it takes lot of time to just be sure, because once you develop a product and you give it to the market, if something goes wrong, you have to pull back everything, and that gets heavy cost. You see some of the car manufacturers, okay, so they want to have an edge with their competitors. So in haste, sometimes they produce the product and take a risk in giving it to the customers. Then in the field, customer finds this problem, that problem. Again, they have to pull back all those cars, and again they have to replace it with the new components, right? So this adds money to the company. So company is not willing to spend or extra money for this costs which are incurred in replacement, right? So they give a warranty, right? When you buy a product, they give a warranty, right? Warranty and guarantee are two different terms. I hope you know that. In guarantee, they will replace the entire product, and in warranty, only the faulty component will be replaced. So in that sense also, company is losing money, and it is creating bad name in reputation terms. So prototype is a vital component in design and development. Okay, the quicker you make a prototype of an object, the faster will be the delivery of the object to the customer. That's the case, right? So we are dealing with the prototype development, right? First we need to make the prototype fast such that the delivery of the final component to the customer will be easy. So I have told you earlier, like 3D printing is not a fast process. It's a slow process, and it takes hours to develop a product, even days. So why we are calling it additive manufacturing, and we are calling it a rapid prototyping. So the development of prototyping, that time is reduced over here. So we are calling it a rapid prototyping, even if the process is pretty slow compared to your conventional process. In conventional process, like in milling, drilling, turning, okay, so this process is a very fast process. They very quickly remove material from workpiece and they give you the final product. Whereas this is completely reverse. It's a very slow process. Okay. So these are the contents of my discussion. Will be terms of reference, some definitions, capabilities of additive manufacturing, geometric capabilities, material capabilities, and classification of additive manufacturing in terms of American standard, tool manufacturing based on raw material stock. So there are various terminologies that we can hear or we know. 3D printing. Okay. So basically 3D is the solid object. Okay. The three-dimensional space is there, X, Y, Z. So this is 3D printing, and why you are calling it as a printing? Because you know we have seen 2D printing, like printing from your printers, right? You have Canon printers or HP printers. You give an impression and it comes up, whether it's a text or an image. So it's a 2D printing. It has only X and Y dimensions. So in 3D printing, it is in contrast because it has a Z axis, right? So three-dimensional object is printed. So lithography is also printing on 2D scale, and when we are adding stereo means it's a 3D printing. Okay. So this lithography is same as 2D printing. This lithography is basically lithography is 2D printing. Okay, so when you are adding stereo, it becomes 3D printing. Okay, now additive manufacturing, basically we are adding layers. We are adding layers while manufacturing the product, so it's called additive manufacturing or additive layered manufacturing. Now since the entire design and development takes place in CAD platform, so we can call it a digital manufacturing. Okay, additive digital manufacturing. So the design of an object, first we are developing it in the CAD platform. So we are digitizing the entire 2D as well as the 3D model in CAD. So we are calling it a additive digital manufacturing. Similarly, layer by layer deposition is taking place in developing the product, in manufacturing the product. So we can call it a layered based manufacturing. So layer by layer manufacturing is taking place, and we can change the orientation of the object. In the previous classes we have discussed like how we can change the orientation of the product in different angles. Okay, so you can place the product in this way, you can place the product this way or inclined, upside down. We can change the orientation while manufacturing, right? So we can also term it as layer oriented manufacturing. And layer oriented manufacturing is like we can change the thickness of the layer also, right? When you are depositing the layer, not necessarily it can be homogeneous and equal in nature. It can be of different layers. The thickness of the layers can also vary. Okay. And next is the solid freeform fabrication. So we are making the solid object from the free-form diagram in the CAD platform. So that has been transformed into a solid object. When you are making a free-form diagram in CAD, that has to be realized in the 3D model, in the 3D printing stage. Okay, so we call it a solid free-form manufacturing. Obviously, digital manufacturing is related to digital mock-up, because we are making the replica of the actual object. Okay, we are making the prototype of the actual object, so we can also call it as digital mock-up. Then direct manufacturing is there, because directly when the CAD system is interfaced with the machine, 3D machine. So directly printing is taking place. Okay? Or sometimes we take the data from the CAD system and we transfer with some storage device into the machine. Okay, or we can take the information from the cloud if it is interfaced with the machine. Then you can directly manufacture it also. Okay, so direct manufacturing also takes place from the CAD media or the CAD platform. Now, direct tooling. Tooling is like we are not making the tools. Right. See, in molding process, you need a mold. Right, any molding process, you need a mold, and that design of mold is very complicated. And this molding process is actually favorable in mass production system. Right, let's say you are making this PET bottles. So the design of this PET bottle has to be first made, and then the mold design has to be made, the cavity of the mold has to be made according to this. Then you give the pellets of the polymers, and then you heat it and inflame it inside the mold cavity. So it will take this shape. Now to prepare that mold, you need some tools. Okay, so that tool you can design and manufacture with the 3D printing. Okay, that is what is called rapid tooling. Okay, rapid tooling or direct tooling. So through 3D printing, you are not making the entire mold of the molding process. You are making the tools of the molding process in a quicker fashion so that the mold can be prepared easily. Right? So 3D and 2D you can easily distinguish nowadays, because 2D, you know, the 2D printers are there nowadays, which give you the impression of any written format or a digitized format, and 3D printing is basically making the three-dimensional object in the three-dimensional workspace. Okay, so this is the, both are very easy nowadays and both are very cost effective. Earlier days it was very costly. Now both these printers are coming almost at the same price. 2D printer and 3D printers are coming at the same price. Okay, so this is very easy and these are affordable. Earlier days it was not affordable, now it is affordable. Both are very much affordable. So this is what we draw in 2D frame, and if you want to make it in a 3D printing, you will get an object like this. Okay, so this is made in 3D printing process, and its 2D impression or 2D image will be in this format. Okay. So 3D printing also known as stereolithography. So lithography is 2D printing, already I have said, and stereo, when you are adding the term stereo, it means 3D printing. Okay. Now 1D is basically a line, 2D will be a laminar form or a plane. Okay. 3D is XYZ. 4D is when you are opening that 3D format with respect to time. It becomes 4D, right? Okay. With respect